Hello, sixth grade students. This is Mr. Kraft coming to you from my home via the magic of high technology. It's been a while since I've seen you, and I look forward to when I'm able to see you again. In the meantime, I'm uploading this video that I'm making talking about decimals. Now, we've done some of this already, but it's been a while. And believe it or not, I suspect that many of you have not been sitting around doing math for fun over the last week and a half, last 2 weeks really. So if you have been, great. But if you've not, that's okay. So let's talk about decimals. And let's talk about how to change a fraction to a decimal and how to divide with decimals. And we've talked about this before, but it's been a while. So let's take something like 3/4, 3/4. You know, the top of any fraction is a numerator, and the bottom is a denominator. So to change a fraction to a decimal, what you want to do, and let me kind of sidetrack here for a second. Let me remind you a little bit. Let me just make up a decimal. You know, if you had a number like 1279, a whole number, you know the first place is the ones place. Then you have the tens place. Then the hundreds place. Then the thousands place, 10,000s, 100,000s, millions, and so on. With a decimal, it goes the opposite. You have tenths and hundredths. The reason I'm saying it, so pronouncing it that way, is so you hear that I'm saying tenths and not tens. Thousandths. There's no such thing as a oneth, because tenths means you cut something into 10 pieces. Hundredths means you cut something into 100 pieces. Thousandths mean you cut something into 1,000 pieces. But if you cut something into one piece where you've not cut it up, it's not a fraction, it's the whole thing. The zero here is not technically necessary. So this here and that are the same. But I like it better if you do that, and I'll tell you why. Some kids, even some adults, make the decimal sometimes so small you almost can't see it. So if I look at that, I'm not sure if that's supposed to be 357, or 357 thousandths, or what have you. If you put the zero there, there's no doubt. I'm not going to make you put the zero there, but if you don't, make a nice big decimal that I can read very easily. Also, this is something about how you read the decimals. And I haven't really talked to you about this in class, so I think I will now, because I think it's worth discussing before we go on and show how to change fractions into decimals, which is reviewing something we've done anyway, after all. So let's take that number again. I would pretty much bet you that if you went out on the streets and asked people how to read this, well, first they would think you were very strange. But probably most people would read that 0.357. I would bet you 99 out of 100 people would read it that way. And I might myself, depending on what kind of mood I was in. Really, though, it's probably better for us to learn how to read it using fractional language. Because if you think about it, what you do is you count your places, tenths, hundredths, thousandths. So the very last place is the thousandths place. So then what you do is you read what you've got and say thousandths. So you would say 357, 357 hundredths. 357 hundredths. And why am I saying that it's probably better to read it that way? Because this tells you what it is. You cut something up into 100 pieces and you have 357 of them. 357 hundredths tells you what you've got. 0.357 doesn't really tell you anything. A long time ago, it must have been almost 17 years ago when I taught at Bluegrass Community and Technical College. No, it was Spencerian College in Lexington, actually. I'm sorry. I had a woman who taught with me. She was from Russia. And she just couldn't believe that Americans read decimals like 0.357. In Russia, they teach it 357 hundredths. Of course, they would say it in Russian, not English. And I know a little bit of Russian, but I don't know the words for fractions. So sorry, that's the way it goes. But if you learn to say it using fraction names, you really understand what it is instead of just saying point such and such and such like we Americans do. So that's something to think about. I will try to use that terminology more myself so you understand what I mean. So let's get back to what we were talking about. How do you change decimals into fractions? I mean fractions into decimals. We will worry about changing decimals into fractions later. That's easy. We'll talk about that later. But right now we want to say decimals into fractions. And we divide. The numerator always goes inside the bracket, and the denominator always goes outside the bracket. We've talked about this before, but like I said, we really need the review. So I'm going to say 3, put the bracket, and put the 4. I'm going to put a decimal after 3, and the decimal comes straight up. And I'm going to add a bunch of zeros. You might not use all those zeros, but you never know how many you're going to need. Well, that's not true. I know how many I'm going to need. I'm going to need 2 because I know that 3/4 is 0.75. Some of you may know that already. But sometimes you'll be working with a fraction where you don't know what it is. So you always want to be prepared to add more zeros if you need. So I'm going to put this 0 out front, which is a filler 0, and then say, 4 goes into 30 how many times? Well, the answer is 7. 4 times 7 is 28. 8 from 10 is 2. That leaves a 2 here. 0. Drop the 0. 4 times 5 is 20. Boom. There's your answer. 3/4 is 0.75. Okay. Now, there are actually different situations that occur. Let's say we had 3/8 instead of 3/4. 3 goes inside. Again, the top's always inside. This time, I'm just going to put 1 0 because you can just add zeros as you need them if you want to. So 3 times 8 is 24. 4 from 10 is 6. That leaves out a 2. 2 minus 2 is 0. Add a 0. 8 times 7 is 56. 6 from 10 is 4. And of course, you borrowed. 5 minus 5 is 0. I still have a remainder. As long as I have a remainder, I keep going. 0. Drop the 0. 8 times 5 is 40. Well, I no longer have a remainder, so 0.375 is my answer. Okay, I just now said, as long as I have a remainder, I have to keep going. Well, that's not quite true. Let's say I had 1 over 3, and I divide 1 by 3. 3 times 3 is 9. 3 times 3 is 9. Well, you see it's repeating. And so if I were to keep going, as long as there's a remainder, I'd be going for it all eternity. And none of us has that much time to spare to do a math problem. So you could say 0.3 and put a bar over it. The bar means repeating. More often, you would round it. Like if I said round to the nearest tenth and say 0.3, then remember, if the next thing 4 and above, give it a shove. 5 and above, give it a shove. 4 and below, leave it alone. This is below 5, so the 3 does not round up, so I'd stop. Or if I said to the nearest hundredth, well, then I'd go one more place, and then I'd have 0.33. The 3 leaves that alone, and so forth. Sometimes it doesn't repeat on the first go round. Like if you had 1/6. So 6 times 1 is 6, drop of 4. 6 times 6 is 36. 4. Now it repeats. Now, if you use the bar notation, the bar goes only over the 6. The 1 doesn't repeat. It's only the 6. If you rounded it off, it would be 0.1. 5 and above, give it a shove. So that goes up to 7. So that's what you do there. 7 is a lot of fun. Anything that has a 7 in the denominator is going to be kind of crazy. So 2 times 7 is 14. That gives 6. 8 times 7 is 56. That gives 4. 5 times 7 is 35. That gives 5. 7 times 7 is 49. That gives 1. 7 times 1 is 7. That gives 3. 7 times 4 is 28. I'm running out of room here. And my remainder is 2. So I'm back. So technically the answer to this, the bar goes over the whole darn thing. So 0.285, 285, 285, 285 forever. That's much farther than you would normally go. Tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. Unless you are doing research on bacteria or something like that, or atoms, you're not going to go down to the millionths. For what your textbook does, we're not normally going past the thousandths. So you would round something crazy like this. If I said round to the nearest tenth, well, this is your tenth place, the 2. 8 makes it go up to 3, so that'd be the nearest tenth. If I were to round it to the nearest hundredth, I'd say 2. 5 makes the 8 go up, so that'd be the hundredth. The farthest I would ever ask you to go is the nearest thousandth. So I'd have 0.286. Because a 7 is bigger than 5, that makes the 5 go up to 6. So that is how that would work. Okay. We're going to talk about this a lot this week. I'm going to leave it at that. Your assignments will be posted in Google Classroom, and I hope to see you soon. Goodbye.